Assalamualaikum. Okay, so today we will embark on an essential topic within our water supply course, which is the third topic already. The topic is drinking water quality. Okay, so as future environmental health professionals, your understanding of this topic is very crucial. Safe drinking water is fundamental to public health, and ensuring its quality is one of our most important responsibility. So in today's session, we begin by diving into the first subtopic, which is the parameters for assessing drinking water quality. Okay, so for the learning objective, at the end of the session, you all should be able to explain the significance of a few indicators, which is the microbiological, chemical parameters, and also physical parameters. Okay, so for the first learning objective, students should be able to explain the significance of these indicators. For instance, the coliform bacteria are used as a general indicator for potential contamination, while E. coli specifically indicates fecal contamination. Understanding the presence of these microorganisms helps in assessing the risk of waterborne diseases and ensuring the microbiological safety of drinking water. And the second one, you all should be able to describe the significance of chemical parameters that impact drinking water quality, including the pH level, water hardness, the presence of heavy metals like lead and mercury, nutrients such as nitrates and phosphates, and organic chemicals. You should be able to explain how these parameters affect water safety and quality. And of course, the last one, describe the physical parameters. You all should be able to explain the physical parameters used to assess drinking water quality, such as turbidity, color, odor, taste, and temperature. You should be able to discuss how these factors influence the overall acceptability and safety of drinking water. Okay, let's go to the overview of the topic. Okay, so water quality parameters are crucial for assessing the safety and suitability of water for various uses, especially drinking. Monitoring of these parameters ensures the protection of public health by detecting contaminants that could cause illness. Additionally, it helps maintain environmental health and sustainability by managing water pollution and safeguarding aquatic ecosystems. To effectively assess water quality, we categorize the parameters into three main groups, which is microbiological parameters, chemical parameters, and of course the physical parameters. By understanding and monitoring these parameters, we can ensure that water remains safe for consumption and other users. This comprehensive approach to water quality assessment helps protect public health, maintain environmental integrity, and promote sustainable water management and practices. Okay, so let's dive into the first parameter, which is the microbiological parameters. Microbiological parameters are crucial indicators of the presence of harmful microorganisms in drinking water, which can pose serious health risks. Let's dive into some key microbiological indicators and their significance. Okay, so the first one is of course the total coliform bacteria. Total coliform bacteria include a broad group of bacteria found in the environment, such as in soil or vegetation, and in the intestines of warm-blooded animals. While not all coliform bacteria are harmful, their presence in drinking water indicates the possibility of contamination by soil or other sources that may harbor pathogens. The presence of total coliform bacteria often triggers further testing to identify specific pathogens and to locate and eliminate the source of contamination. Okay, so for the second one is the fecal coliform bacteria. Okay, so fecal coliform bacteria are a subgroup of total coliform bacteria that are found specifically in the intestines of warm-blooded animals, including humans. The presence of fecal coliforms in drinking water is a strong indication of recent fecal contamination, which may include harmful pathogens such as bacteria, viruses, and protozoa. Fecal coliform counts are used to assess the effectiveness of water treatment processes and the integrity of the water distribution system. Okay, so for the last one is E. coli, where E. coli is a specific types of fecal coliform bacteria. While most strains of E. coli are harmless, some can cause severe illness. The detection of E. coli in drinking water is a clear indication of fecal contamination and the potential presence of pathogens that can cause gastrointestinal illnesses. Due to its strong association with fecal contamination, E. coli is considered one of the most critical indicators for assessing water safety. Okay, so microbiological parameter is very important, and protecting public health regularly monitoring of these microbiological indicators helps protect public health by identifying potential microbial contamination in water. This allows for timely interventions to eliminate contamination sources and ensure safe drinking water. Okay, so this is the figure for the source for the fecal contamination, which can be coming from the point source, which include the agricultural activities, industrial activities, municipal and household. And non-point source can be coming from the coastal runoff, rural runoff, forest runoff, and also urban runoff. This include the bacteria, which is including coliform, E. coli, Enterococcus, bacteroides, Clostridium. Virus includes colifish, crustfish, adenovirus, and polymovirus. Okay, so this figure is from Biological Indicators for Fecal Pollution Detection and Soft Tracking, a review paper from Processes Journal, which wrote by the L.E. et al. 2021. Okay, so let's go to the first microbiological indicators. Okay, the first one is of course the total coliform bacteria. Total coliform bacteria is commonly found in environment, for example from soil or vegetation, and are generally harmless. If only total coliform bacteria are found in drinking water, the contamination likely comes from the environment, not from the fecal matter. When only total coliform bacteria are found in drinking water, it likely indicates that environmental contamination from sources like soil, vegetation, or organic matter, rather than fecal contamination. Total coliforms are common in environment and not specific to fecal matter, suggesting the water has come into contact with non-fecal materials. If environmental contamination can enter the system, there may also be a way for pathogens to enter the system. Okay, so the second one is fecal coliform bacteria. Fecal coliform bacteria is a subgroup of total coliform bacteria that specifically originate from the intestines and feces of warm-blooded animals, including humans. Their presence in water is a strong indicator of recent fecal contamination, which can signal the presence of pathogenic microorganisms and a higher risk of waterborne diseases. Okay, so they appear in great quantities in the intestines and feces of people and animals, and the presence of fecal coliform in a drinking water sample often indicates recent fecal contamination, meaning that there is a greater risk that pathogens are present than if only total coliform bacteria is detected. So from this figure, this is the cross-section of fecal coliform bacteria live in the digestive tract of warm farm animals, humans, wildlife, as well as pets. Okay, so the last one is E. coli. It's a subgroup of the fecal coliform group. E. coli can be found in great quantities in the intestines of people and warm-blooded animals. Some strains, however, can cause illness. The presence of E. coli in a drinking water sample almost always indicates recent fecal contamination, meaning there is a greater risk that pathogens are present. Okay, so for this figure, we can see how intestinal E. coli infection affects the body, which include the nausea, fatigue, diarrhea, abdominal pain, vomiting, as well as fever. Okay, now that we have a true understanding of microbiological parameters and their critical role in assessing the presence of harmful microorganisms in drinking water, let's move on to another essential aspect of water quality assessment, which is chemical parameters. Chemical parameters are critical for assessing water quality and safety. They may include heavy metals like lead, arsenic, and mercury, which can cause severe health issues. The second one, organic contaminants such as pesticides and volatile organic compounds, which are harmful even at low concentration. And of course, inorganic chemicals like nitrate, fluoride, and chloride, which can impact health water taste. Monitoring these parameters help ensure safe and clean drinking water. Understanding this chemical also is very vital because they can influence not only the taste and appearance of water but also its safety and suitability for consumption. Let's delve into the specific of chemical parameters, starting with the heavy metals. Okay, heavy metal. Okay, let's go to the characteristics of heavy metals. Okay, heavy metals are toxic even at low concentration and can accumulate in the body over time, leading to chronic health problems. They do not degrade easily and can remain in the environment for very long periods. Heavy metals also can build up in living organisms, often reaching higher concentration in organisms at higher levels of the food chain. In water especially, heavy metals can exist in various forms including dissolved ions and particulate matter, making them difficult to move. Okay, so where is heavy metal coming from? Heavy metals can enter drinking water from various sources, including factories and manufacturing plants release them through the waste streams. Pesticides and fertilizers used in agricultural activity can leach heavy metals into water supply, and old plumbing system with lead pipes and solder can leach heavy metal into the water. And additionally, of course, natural mineral deposits can cause heavy metal to leach into the groundwater, and at the end of the day, can leach into our drinking water supply. So here are a table of limits of heavy metals in drinking water and associated health effects. Okay, so here you can see the National Drinking Water Quality Standards of Malaysia and also WHO limit. Okay, and the health effects and the sources of each of the heavy metals. For example, here the lead. Okay, the limits for NDWQS is 10 microgram per liter, same as well as WHO limit, also 10 microgram per liter. And the health effects of lead, okay, neurological damage, cognitive impairment, especially in children. The source is coming from old pipes, industrial waste, and the others such as maybe we go to copper. Okay, the limits for the National Drinking Water Quality Standards of Malaysia is 2000 microgram per liter. Same goes to WHO limit. Okay, and the copper is coming from the health effect of copper is gastrointestinal distress, liver and kidney damage, and the source can be coming from the plumbing, industrial and discharge. Okay, so later you all should read each of these and study each of these heavy metals, the limit of NDWQS as well as WHO, and also the health effects and source. Okay. Okay, so from the study done by Zhang et al. 2023, water quality degradation due to heavy metal contamination, health impacts, and eco-friendly approaches of heavy metal remediation shows that there are a few heavy metals here: the copper, the chromium, the lead, the cadmium, okay, that can cause headache, fatigue, respiratory illness, cardiovascular illness, liver damage, gastrointestinal, and as well as kidney damage. Okay, so the next is organic contaminants. Organic contaminants, the characteristics of these contaminants can be harmful even at low concentration, posing significant health risks. Some organic contaminants do not easily break down in the environment, leading to prolonged exposure risks to human health. Many organic contaminants, especially volatile organic compounds (VOC), can easily evaporate and contaminate air and water. Organic contaminants can dissolve in water, making them difficult to detect and remove. So the source of organic contaminants in drinking water can come from various sources, including agricultural activities, industrial processes, household products, urban runoff, and wastewater treatment plants. For agricultural activities, as for example, pesticides and herbicides used in farming can run off into water bodies and contaminate drinking water supply. While industrial processes, the factories and manufacturing plants can release organic chemicals through waste disposal and emissions. Everyday products like cleaning agents, paints, and solvent can introduce organic contaminants into water system through improper disposal. As well as stormwater can carry organic contaminants from roads, parking lots, and lawns into the water system. The last one, of course, the wastewater treatment plant, which can produce a very huge amount of effluent, which is incomplete treatment of sewage, and industrial wastewater can result the contamination of drinking water by the organic contaminants. Inorganic contaminants are often chemically stable and do not easily degrade in the environment, leading to long-lasting contamination. Same goes as the organic contaminants previously. Many inorganic contaminants are toxic to humans and wildlife even at low concentrations. Inorganic contaminants can dissolve in water, making them challenging to detect and treat, and unlike organic contaminants, inorganic contaminants do not break down through the biological processes, making them persistent in water supply. The source of inorganic contaminants include agricultural practices, industrial activities, mining operation, urban runoff, and as well as natural sources. We've now covered the various chemical parameters that play a crucial role in determining the safety and quality of drinking water, such as the heavy metal, organic contaminants, and also inorganic contaminants. These chemical characteristics significantly impact the safety and the overall composition of the water we consume. Next, let's shift our focus to the physical parameters of water quality. Physical parameters including turbidity, suspended solids, color, odor, pH, and temperature are equally important. They not only influence the aesthetic qualities of drinking water, but also affect the treatment of processes and the overall safety of water supply. By monitoring these physical characteristics, we can ensure that drinking water is not only safe and free from contaminants, but also palatable and visually appealing to consumers. Let's explore these physical parameters in detail, starting with turbidity and its significance in water quality assessment. So now that we discussed chemical parameters, let's summarize the key physical parameters crucial for assessing the quality of drinking water. Okay, Okay, so the first one is turbidity measures the water clarity due to suspended particles. It's important because high turbidity can indicate the presence of pathogens and affect treatment processes and health risks. The standard for turbidity is 5 NTU. Okay, the second one is suspended solids are particles not dissolved but suspended in water such as silt, plankton, industrial waste. These solids affect water quality and treatment efficiency and can carry pollutants. Color refers to the appearance of water influenced by dissolved organic matter, metals, pollutants. Unusual color indicate contamination and affect the aesthetic quality of water with a standard of 15 TCU. While odor is influenced by organic materials, chemicals, as well as natural processes. Unpleasant odors can signal contamination and affect the acceptability of drinking water. While pH measures the acidity or basicity of water on a scale from 1 to 14, with 7 being neutral. It affects the solubility and biological availability of chemicals and is crucial for disinfection and the health of aquatic life. The acceptable pH range is in 6.5 to 9. And temperature measured in degrees Celsius or Fahrenheit influences chemical reactions, biological processes, and gas solubility. It also affects the comfort and taste of drinking water with an ambient range of 25 to 28 degrees C being the ideal temperature. And the last one is the most important is residual chlorine. Residual chlorine refers to the amount of chlorine remaining in water after disinfection. It ensures ongoing disinfection to prevent microbial contamination, but too much chlorine can affect taste and health. The standard for residual chlorine is between 0.2 and 5.0 milligram per liter. Okay, so monitoring these physical parameters ensures that drinking water is safe, palatable, and free from contaminants, thereby maintaining public health and environmental quality. So, for the summary, water quality parameters are essential for ensuring safe drinking water. Microbiological parameters such as coliform bacteria, E. coli, and other pathogens indicate contamination and potential risks. While chemical parameters include toxic heavy metals, organic pollutants, and inorganic chemicals that can adversely affect health. Physical parameters like turbidity, color, odor, pH, and temperature influence water clarity, aesthetic qualities, and treatment processes. In Malaysia, key strategies for improving water quality include enhancing water treatment processes, regular monitoring, upgrading infrastructure, and enforcing strict pollution control measures. Future efforts should focus on adopting advanced technologies, building climate resilience, and ensuring equitable access to clean water through collaboration between government, industry, and communities. Each of these parameters provide us with critical information about the quality and safety of drinking water. By regularly monitoring this parameter, we can ensure that our water supply remains within the safe limits set by health and regulatory standards. Throughout today's lecture, we explore these parameters in greater detail, discussing their significance, the methods, the measurement, the standards set by organizations such as WHO and local regulatory bodies. Understanding these parameters will not only help you in your professional roles but also empower you to contribute to the ongoing efforts to provide safe drinking water to communities. So that's all for today. Thank you for staying with me in this topic. See you again in the next topic. Assalamualaikum and thank you.